This presentation looks at the idea of atom economy. By the end of the presentation, you should be able to say what's meant by atom economy. If you're given the balanced equation for a reaction, you should be able to make a rough prediction of the atom economy or calculate a precise value for it. And finally, you should be able to say the significance of something having a high or a low atom economy in terms of the environment and economics. So we'll start with an overview of what do we actually mean by atom economy. Well, atom economy can be thought of as a measure of the mass of atoms used in a reaction or in a process that end up in the desired or useful products rather than ending up in waste products that need to be disposed of. So if you have a reaction with a 100% atom economy, that means that all of the atoms that you're putting in go into your desired product or products. There are no waste products produced. If you have a reaction with only a 40% atom economy, that's just 40% of the mass of atoms going into the reaction that end up in your useful product, which means that 60% of the mass of all the atoms that you put in end up in products that are for disposal, waste products. We'll look now at how you actually calculate a value for the atom economy of a reaction. And so let's take an example. This process shows the reforming of alkanes to produce things like benzene. So the intended product from this reaction is the benzene. In order to calculate atom economy, we need to know the relative formula mass of each of our products. So for the benzene, that's C6H6 gives 78, and for the hydrogen, H2 gives 2. It's no different from saying the molar masses of the products. The equation for calculating atom economy is this. So on top you have the relative formula mass of your useful product, whatever you're trying to make, and on the bottom the relative formula mass of all the products, and then you times by 100 to get a percentage. Sticking the numbers in from the equation, we therefore have 78 on top. The balanced equation shows just 1 mole of benzene being produced, so 78. On the bottom we've got everything in the product, so the 78 for the 1 benzene, and then note in the equation there's 4 hydrogens, so 4 lots of 2, and times all of that by 100. That gives us 78 divided by 86 when we work out what's on the bottom, times by 100, and that comes out at 90.7%. So we can say the atom economy of this way of making benzene is 90.7%. 90.7% of the mass of all the atoms used ends up in our intended product, and the rest is waste. However, we could question that and say, why are you throwing away hydrogen? This is a useful substance. Don't throw it away. It's not waste. Collect it and sell it. Use it somehow. Now, in that case, our useful products become all the products, and so the top of the fraction in the equation now is equal to the bottom, and so our atom economy will be 100% by definition. I should just point out here that sometimes when you see the method for working out atom economy written down, you'll see that it's defined as being the total relative formula mass of all the useful products, like here, but divided by the total formula mass of all the reactants. Now, it makes absolutely no difference because, of course, all the atoms in the reactants are the same as all the atoms in the product. So for the bottom of this fraction in the equation, whether you say the total formula mass of all the reactants or the total formula mass of all the products, it's going to give you the same number, so it makes no difference. It makes sense just to use the products because you've already worked out the formula mass of one of the products to do the top of the fraction, and so just make use of that and stick with the products for the bottom of the fraction in the equation. Another example to show how this works, this is the process that takes place when you do the electrolysis of an aqueous solution of sodium chloride, and you get hydrogen, chlorine and sodium hydroxide as the products, and we're going to say that we're going to carry out this process as a means of producing chlorine. So chlorine is our desired product here. Now if we use the atom economy equation introduced before, we'll get this. So on the top is our useful product. The balanced equation shows just 1 mole of chlorine in the products, so relative formula mass of chlorine is 71, so we just put 71 on top. On the bottom we put the relative formula mass of all the products, so 2 for the H2, 71 for the Cl2, and then the relative formula mass of sodium hydroxide, NaOH, is 40, but there's 2 moles in the balanced equation, so we put 2 times 40. And then remember, we're going to times everything by 100 to get it as a percentage. So moving on with the calculation, The top is 71. The bottom, when we've added everything up, should be 153 times by 100, and that's going to come out at 46.4%. So the atom economy for this process of making chlorine is 46.4%. But, just like before, we can question this and say we could make it 100%, because once again, hydrogen is a perfectly valuable substance, and sodium hydroxide is also a very widely used chemical. And so what's to say chlorine here is our only useful product? Let's treat them all as useful products, collect them all, sell them all, 100% atom economy. The balanced equation here shows a reaction that used to be carried out quite widely as a way of producing hydrogen. So the desired product in this reaction is the hydrogen H2. Hopefully you're starting to feel relatively confident about this atom economy idea now, so pause the video, have a go at working out the atom economy for this reaction if the desired product is hydrogen. And your calculation should look like this. So note we've got 2 moles of hydrogen in the product, so we've got to have 2 times 2 on the top, and then on the bottom the 1 carbon dioxide 44 plus the 2 hydrogens, and then we're going to multiply by 100. That gives us 8.3% as our atom economy. Very low. Sometimes when you're asked about atom economy, you don't need to do a calculation. You can just estimate the atom economy. And let's have a look at this in action. So imagine a situation where you've got a reaction that produces only one product. For instance, an addition reaction of an alkene here, ethene reacting with hydrogen chloride to make chloroethane. We don't need to do a calculation. There's only one product. And so therefore our useful product is all of the products, and that means that the atom economy has got to be 100%. If on the other hand you have a reaction that produces more than one product, so dehydration of an alcohol for instance, ethanol here dehydrating to make ethene, then if our desired product is the ethene, we're now guaranteed to have something less than 100% of atom economy, because our useful product is now not all of the atoms. But we can say that's only true, of course, if the other product or products are truly waste products. If we can capture them, make use of them, then once again our atom economy is back up to 100%. So read a question carefully on atom economy and just make sure that you're clear what exactly is being counted as useful product from the reaction. The final thing to discuss about atom economy is its significance. So what if something has a high or a low atom economy? And we can discuss this in various ways. So when you get asked a question on this, read it carefully and see what they're asking you to comment on in terms of. First of all, we'll look at what it means in terms of waste. And from what we've said so far, hopefully you could answer this yourself. If we have higher atom economy, then we have less waste products proportionally. So with 100% atom economy, no waste products at all. And as we head down from 100 towards 0, then we're getting an increasing amount of waste products. Secondly, we can think of the significance of atom economy in terms of the environment, and this is connected with the waste very much. So if we have a high atom economy with low waste, that means there'll be little waste to be disposed of, and hence little risk of pollution to the environment from the process. The lower and lower the atom economy becomes, the more and more waste products we have. That means more and more risk of pollution as those waste products are disposed of in some way. And thirdly, economics. Again, this is connected with the waste, because waste disposal is expensive. And also waste represents money that you've spent on precious raw materials that don't end up in the product, they're just going in the bin. So with a high atom economy, let's say 100% atom economy, that's fantastic from an economical point of view. You don't have to spend any money on waste disposal, and all of the money, every single atom you purchased for your raw materials is ending up in the product that you sell. So good income from the process. On the other hand, if you have a low atom economy, you're having to spend all that money dealing with the waste that you've produced, and you're throwing away most of the atoms that you bought.